Hello everyone, today we'll be doing question number 3 from the RMO 2018 question paper. So now in this question number 3 it has been said that for a rational number r, its period is the length of the smallest repeating block in its decimal expansion. Okay, so for example, if we have the number r which is equal to 0.123, 123, 123. So as you can see, 123, after every three numbers, basically after 123 again 123 is repeated, again 123 is repeated. So it basically is the period, it has the period 3. Now if S, capital S denotes the set of all rational numbers r of the form r is equal to 0.abcdefgh. So as you can see, it has the period 8. We need to find the sum of all elements of S. So this is what we need to find out. So now what we'll try to do is that let Sn be the set of all numbers having period small n. Okay, and sigma n be the sum of all elements of the set Sn. Okay, this is what we know. So we'll find out basically the various structures. So now if we have a number of the form 0.x bar, so basically it has period 1. So 0.x bar we mostly write it as x by 9. Now if we have a number of the form 0.xy bar, so we have 0.xy, 0.xy, xy, something like that. So such numbers are normally written in the form xy by 99. And now if we have a number of the form at 0.xyz bar, so we write it as xyz upon 999. Okay, and this goes on. Okay, so this is what we know. Now let us concentrate on the set of the numbers having period 1. So if we have S1, so S1 will basically have the number 0.1 bar, then 0.2 bar, then 0.3 bar, and this will go on up till the number 0.9 bar. Okay, so what is basically we can write these numbers as 1 by 9, 2 by 9, 3 by 9, and it goes on up till the number. We can write it down as, we cannot write 9 by 9. 9 by 9 is not possible. Basically it is 9 bar is not possible, 0.8 bar. Okay, so as you can see in this case, this is basically the format of 8 by 9. Okay, so now, so thereby this can be written in the format of, therefore if we find out sigma 1 will basically 1 by 9 plus 2 by 9, and it goes on up till the number 8 by 9, and the summation of this series is normally equal to, since we have 8 elements, divided by 2 into 1 by 9 plus 8 by 9. So this will be normally equal to 4. Okay, this is equal to 4. Now let us go on to S2. So S2 will be basically consisting of the number 0. We'll start with 0.1 bar, then 0.02 bar, then 0.03 bar, and this goes on up till the number 0.98 bar. Okay, so these numbers are normally written in the form minus. Also this S2 elements will again subtract the elements which has period 1 from these elements, because if we have some suppose 1 1, so basically it is period 1, but we can write 1 bar, 1 bar, 1 bar, whatever. So this will be basically, we'll subtract the elements 0.1 bar, then 0.2 bar, and it goes on up to the number 0.8 bar as discussed earlier. So now, so therefore sigma 2, which is the sum of these elements, will be basically equal to 1 by 99 plus 2 by 99 plus 3 by 99 up till we have 98 by 99 minus the summation of this structure is basically equal to sigma 1. Okay, so this gives us, we have 98 by 2 into 1 by 99 plus 98 by 99. So basically this is the number of terms divided by 2 into the first term plus the last term. This is basically the formula for finding out the sum of a AP series, we can say. And minus sigma 1 is, we know it is equal to 4. So now 98, so 99, this is equal to 1, and so we have 49 minus 4, so and sigma 2 is basically equal to 45. Okay, now we'll go on to find out the value of, so now we will go to not S3, we'll go to S4. So now why are we going to S4? Since we are basically concerned with finding the sum of the numbers having period date. So if a number has a period date, so it will basically have either period 1 numbers included, either period 2 numbers included, or period 4 numbers included. We cannot have period 3 or period 5, since if we have period 3 then we have ABC, then we'll have DF, but another period cannot be accommodated since we have 8. Okay, so we'll have only up till S4, S1, S2 and S4. Sum of elements having the set period basically 1, 2 and 4. So S4 will be basically equal to, if we find out the numbers, so this will be basically 0.0001 bar, then we'll have 0.0002 bar, and it goes on up till the number 0.9998 bar. Okay, and we'll be subtracting the set having elements S1 union S2. So S1 union S2 elements will be subtracted. Okay, so therefore if we find out now sigma 4, so sigma 4 will be basically equal to 1 by quad 9 plus 2 by quad 9 plus, and it goes on up till the number 9998 by quad 9 minus sigma 1 plus sigma 2. Okay, so now if we find out this number, so this will be 9998 terms divided by 2 into the first term plus the last term minus sigma 1 is equal to 4, sigma 2 is equal to 45. So now this will be giving us ultimately 4999 minus 49, so this will be equal to 4950. Okay, so sigma 4 is equal to 4950. So now if we are finding out S8, so S8 will contain the number 0.00000, and then we have another 0 and 1, so this structure, and then we'll have 0.0070 zeros basically, and then we'll have a 2, and it goes on up till the number 0.999999 and another 9 and then 8. So up till this structure minus will be having the sets S1 union S2 union S3. Okay, so now if we find out sigma 8, so sigma 8 will be basically equal to, if we take 1 by, then how many 9s we'll have in the bottom? So we will have 8 9s. So into 1 plus 2 plus 3 up till the number 7 9s, and then an 8 minus sigma 1 plus sigma 2 plus sigma 3. Okay, so this will be basically equal to, if we do the entire multiplication, this will ultimately give us 4999, then a 5, and then we'll have 3 zeros. So this will be the sum of all the numbers having period 8. So 4999500 is the answer. So this is how you solve this question, which came in the Regional Mathematical Olympiad of 2018. We'll be solving the next questions in the subsequent videos. In case you have any trouble understanding this problem and the approach that we followed over here, then you can comment in the comment section below and we'll try to get back to you. Thank you very much for watching this video.